Hello viewers, in today's class we are going to discuss one very important problem from three-dimensional geometry related to perpendicular lines, right? So here we are going to solve one important problem. Here we have to find the value of lambda if these two lines are perpendicular to each other, right? So here we are given the problem that two lines are given and we have to find the value of this unknown lambda if these two lines are perpendicular to each other, right? So let us first see the condition in three-dimensional geometry for two lines to be perpendicular, right? So now let us consider two lines, say L1 and L2 in three dimensions, right? So the standard form of the equations for the two lines L1 and L2 can be given like this: x minus x1 over a1, y minus y1 over b1, and z minus z1 over c1, right? And suppose the line L2 has the equation x minus x2 over a2, y minus y2 over b2, and z minus z2 over c2, right? Suppose we have these two lines L1 and L2, right? So here we are considering the general case. So here this line L1 is passing through the point x1 y1 z1, x1 y1 z1, and the direction ratios of this line L1 are a1, b1, and c1, right? And similarly this line L2, it passes through the line through the point x2 y2 and z2, and the direction ratios of this line L2 are given by A2, B2, and C2, right? Now suppose these two lines L1 and L2 are perpendicular to each other, right? So it implies that the angle between these two lines is say theta, and theta is pi by 2, right? So the condition for these two lines L1 and L2 whose equations are given in this form is given by A1, A2 will multiply the direction ratios A1, A2, plus then we have B1, B2, and then we have C1, C2, and the sum of the products of a1, A2, then B1, B2, and C1, C2 must be equal to 0, right? So this is the condition for two lines L1 and L2 to be perpendicular, right? So now let us apply this condition to these two lines, right? So let us take this line as L1 and this line as L2, right? So here we have to keep one thing in our mind, that whenever we have to apply this condition, the equations of the two given lines must be reduced to these two forms, right? So here we can easily see that these two equations are not of these two forms, right? So let us first convert these two equations into these two standard forms. So let us first consider this line L1, right? So L1 can be written as, here we have x minus 5 and 5 lambda plus 2, right? Okay, now see, here we have 2 minus y, and see, here we have y minus y1. So we must write 2 minus y as a negative of y minus 2, and here we have 5, and see, here we have 1 minus z. So here we have z minus z1, right? So we should write 1 minus z, taking negative sign common, we can write it as z minus 1, and here we have minus 1, right? So now we can simplify this equation. We can write x minus 5 over 5 lambda plus 2, and here we have we can take this negative sign in the denominator, right? So we can write y minus 2 over minus 5, and here this negative and this negative get cancelled, so we are left with z minus 1 over 1, right? So now this is the form of the line L1, which is exactly same as this equation, right? So let us do the same thing with this line L2. So here we have x over 1. So x over 1 can be written as x minus 0 over 1. And here see we have 2y plus 1, right? And see here we have simply y, right? So the coefficient of y in this case is 1. So we must take 2 common from this term, that is 2y plus 1. So we can write 2 here, then we have y plus half, and here we have 4 lambda, right? And here we have 1 minus z over minus 3. So we can write a negative sign, we can take common here. So we have z minus 1 divided by minus 3, right? So now L2 can be written as x minus 1. Here we can x minus 0 over 1. Here we have c, we can cancel this 4 with this 2. So we have y minus half, and here we have 2 lambda, right? So minus and minus becomes plus because we should write the equation exactly of this form, and here negative sign get cancelled, so we are left with z minus 1 over 3, right? So this is the exact form of this line L2, right? Now if we compare L1 with this equation, then the direction ratios A1, B1, C1 of this line L1 are given by 5 lambda plus 2, 5 lambda plus 2, then we have minus 5, and then we have 1, right? And similarly in this case L2, the direction ratios of L2 are given by 1, then we have 2 lambda, then we have 3, right? So once we have got the values of A1, B1, C1 and A2, B2, C2, we can apply this condition, right? So according to this condition, A1, A2, so here we have A1 is 5 lambda plus 2, A2 is 1, so here we have 1, and B1 is minus 5, and then B2 is 2 lambda, and then C1 is 1, and C2 is 3, right? So now we have a linear equation in lambda, so we can simplify it. So we have 5 lambda plus 2, here we have minus 10 lambda, and here we have plus 3, right? So 5 lambda minus 10 lambda is minus 5 lambda, and 3 plus 2 is 5. So we have a simple equation. So minus 5 lambda is equal to minus 5. So lambda is minus 5 divided by minus 5, that is equal to 1, right? So these two lines L1 and L2 are perpendicular when the value of lambda is equal to 1, right? So viewers, this is how we can find out the unknown terms when two lines are given to be perpendicular.